Hi everyone, welcome to this crash course where the goal is to teach you how to program in JavaScript so that you can start making games with it. So as opposed to all the crash courses you find on YouTube on learning JavaScript, they usually teach you JavaScript with the intent of making websites and working in web dev. Now here it's different because I'm teaching you the bare bones of JavaScript so that you can start making games, and then you can start even watching my previous tutorials, which all assume that you have a basic understanding of JavaScript. Now, why learn JavaScript for making games? So that's a good question you might have asked yourself, and yeah, I'm here to answer it. So JavaScript is a very accessible language. It's a very sought after skill. That means that with JavaScript, you can work as a web dev. So why not use the same knowledge, same tools to make games, and especially web games. So games that can run on the web without having to download or install anything. And that's the first advantages of web games and using JavaScript for making those games is that you don't have to install anything as a player, which reduces the friction. It's especially an advantage in game jams and especially an advantage when you're a new game developer trying to build your reputation. So by making a bunch of smaller web games, you can not only build your skill as a game developer, but also more easily amass an audience or a potential players. Now, the advantage of doing this in JavaScript is because JavaScript is the lingua franca, I think that's how you say it, of the web. That means that when you make your game in JavaScript, things load fast and are snappy. So if I press, this is a game I made, a Pokemon style game, I made in JavaScript. So I have even like 60 FPS, etc. So yeah, if you were to make the same game in Unity, which has a web export, it's usually bloated, very slow to start. I had only bad experiences playing Unity games on the web. Now, the other advantage of using JavaScript to make games is that you're not stuck on the web. So if you want to make a game on Steam, you can relatively easily transfer your game, convert your game into a desktop application using Tori or Electron or some other technologies. I have a tutorial on my channel teaching you how to make this, how to do that, to have a game that is written in JavaScript but works on desktop. A prime example of this was Vampire Survivors, which was a very popular game on PC, which was a web game that was transferred into an Electron application. So you can have PC game, you can publish your games on Steam. So that's another advantage without having to change your tools. You can also do the same thing for mobile, sorry. So with one language, JavaScript, you can make games for the web, desktop, and mobile. Now the only missing part here is the consoles, and for consoles I don't worry much about it because if you can make a very successful game on PC, usually it makes business sense to just pay a porting house to port your game to consoles. So as an indie developer, you really should be focusing on making a great game, and if you want to make money, usually you have to go to Steam to do that, and you can do that with JavaScript. And I would say the last advantage is the transferable knowledge you have with web dev. So imagine you're a new developer, you just started out, you wanted to learn programming, and you learn JavaScript and you realize like making games is fun, but I would not be able to make this a sustainable career or something like that. Well, the tool, JavaScript, the language you learned, is actually useful for making web applications and websites. So the knowledge you have here is transferable into in-demand skill, which you can use as a software engineer, etc. So, and vice versa, if you're a web dev already, you might want to try to make games and you cannot justify the investment of time into learning maybe Unity or Godot, etc. So it might be actually better for you to just stick to JavaScript and make games with it. And there are many libraries you can use in JavaScript to make things easy. And one of them that I teach on my channel, Caplay, is really fun to use and really quick to use, that it makes it very fast to make games with it. So that's that. So what's the promise of this video? So by the end of this video, you should have a basic understanding of JavaScript, even if you have never programmed before. And you should be able to have made your first game. So we're going to try to build, by the end of this video, a first simple game, either a platformer or something very simple. And then after that, you are ready to watch my previous tutorials. I can show them to you here. So I have tutorials on how to make a Metroidvania game, how to make a Zelda-like fighting games, etc. And of course, you can use other resources, and basically you can dive into it. So after that, if you want to go to web dev, you can follow tutorials, etc., and read documentations, etc. So this is meant as a gateway to JavaScript, but also like game development in JavaScript. So it's a gateway to your programming career, maybe. So let's get started. So you will need Visual Studio Code here, which is the the code editor that I'm gonna use. You don't need it. If you're not a beginner, let's say you're coming from another programming language, let's say Python, you can use whatever you like that is a code editor like Vim or whatever. But I suggest that if you're a beginner, an absolute beginner, you have never programmed before, you pick this editor, so you're gonna have the same thing as me. VS Code, by the way, if you don't know, is really like the major code editor for web developers. So here I have a window that contains VS Code. So to open a new project, you go to File and then open a new folder. So first of all, I recommend that you create a folder and then you open that folder, and it's going to open it up for you here, an empty window with your empty folder. By the way, I forgot to mention, but this tutorial assumes that you have basic computer skills. So that means you know what a folder is, etc. And yeah, it might sound surprising, but for some people, it's not something that they know, etc. So usually, if you grew on the iPad, you might not know what a file system is, how it works, etc. If you're used to any like real operating system, in the sense that it's either Windows, Linux, or Mac OS, you should be good when it comes to following this tutorial, this crash course. All right, so what is the shortest path to have your JavaScript code running? So I'm going to create a file by clicking on that button, and I'm going to call it main.js. It's going to be the entry point of our project, of where we're going to write our JavaScript code. So I'm going to first create that file, write some JavaScript code. So here, if I do, you might assume that you write your code in that file, and then you click on a big green button somewhere to run the code. And this is not how we do it in the JavaScript world. So how you do it is you need to create an HTML file. I usually like to call it index.html, but it doesn't matter. It has to be called .html. So usually JavaScript is paired with HTML and CSS, which are other programming languages. They're domain-specific programming language. That means that they're not a general-purpose programming languages like JavaScript is. So let me explain just a brief overview of what HTML and CSS are, but I'm not going to teach you them. I'm really not going to dive into it. I'm just going to teach you the bare minimum of HTML you need to get JavaScript onto your web browser and running. So index.html. So HTML is a language used to make a web page. So describe a web page. You have many tags. For example, the basic tag is the HTML tag, which signifies like that you're gonna create a document, a web page. And then you have the body tag, which is going to, not bot tag, the body tag, which is going to contain the content of your web page, and etc. So the body tag, the way tags are written in HTML is you need those thingy, and then you need to have a closing tag, an open tag and a closing tag. And then here the body is essential. And then within the body, I'm going to put a script tag, which is the tag used to load JavaScript files. So the way script tags work is that you have the tag here, and you have a source attribute where you define where to find your JavaScript file. Here, since we are on the same level within the folder, the path is going to be main.js. So you could even remove that and then do main.js. If you were to create a folder within that learn.js folder, which is the folder I created for this project, when you created the project, you would have gone here, maybe open a folder, and then you would have a different name. But feel free to name it as you want. It does not matter at all. So if I were to create a folder here, I'm going to call it source, or I'm just going to call it code. and then I put my main.js within it, here the path is going to be code/main.js. So that's how it would work. Now the first statement we're gonna write, the first line of code we're gonna write is going to be console.log. And as the name implies, it's going to log something, the thing you pass in within the parenthesis here, to the console. The console is in your web browser. When you press F12, this is the console. So if I were to, depending on your browser, you should have a symbol. So here you have this symbol, console. This is because I really have a big font, so usually you would see them displayed here, but since I've increased the font so much, I need to click on the plus to actually see the console here. So if this is the console, and this is where the output of your JavaScript code will appear. So now here, let's say I want to write a message to the console. I need to pass in what is called in programming a string of characters. So bunch of characters that makes up a string. So hello world is a string of characters. So you have the character H, character E, L, L, O, space character, and then W. So this is a character, even if it's not visible to the eye, it is a character, and W, etc., etc. And it needs to be put within quotation marks. So now everything should be all right, but we still don't have a way to run the code. So the basic way, I would say, is you would just open this in a web browser and you would get the result. But usually the preferred approach is to have a local web server that runs from your computer that is going to run the code and run the web page. This local server is usually called localhost, and there are many ways to run one. But the simplest way, if you're using VS Code, is to go to the extension marketplace, type in live server, and you're going to get this extension, which, as the name here, launch a development local server. So you cannot really see here. So install it. Here it should be written install, but since I have already installed it, it's going to write uninstall. So install it. Once this is installed, go back to your project, and then here below you should see a go live button. So click to run a live server. If you click that, it's going to open up a window. Now I'm just going to copy the address because I'm going to open it in this page. So here we go. So by the way, look at the description to have all the links you need, for example, where to install VS Code, etc. So here's the local host server, the address that was given to me, and then click on that. So by default, live server should open into your default browser. But here I'm using a different browser for recording this tutorial. That's why I copied and pasted manually the address here. Now here you have a blank page because as I said, HTML is actually the language used to write the content of a web page, but JavaScript is a language used to have animations and logic, etc. So initially, when JavaScript was created, it would run only on web pages like that as a supporting character, I would say, just to add animations to HTML pages, so the actual web pages. But as the language evolved and you could do more stuff with it, it is now possible to make games with it. So here we go. So now I'm going to open up the F12, the console tab. You can also open this console tab using, I think, Command Shift I if you're on Mac OS, but it's F12 on Windows. And you can see we can have our hello world output message appear here. This is the console. So we write our code in our main.js file here, and then it's going to appear. So if I, instead of hello world, I say hello JS legend, and you can see that it updates here. So now we're ready. We have our basic programming environment ready. Later on, we're going to see more advanced tools and a different setup that is more closer to what is actually what's used professionally. All right, so now let's start actually learning the core concepts of programming in JavaScript. So the first core concept I want to mention, it's the core concept 0, I would say, is how code is executed. So I'm assuming that you have zero knowledge of programming, and then that means like code is usually run as a like a recipe. Imagine it as a recipe of steps you need to follow, and those steps are extremely detailed, because if you do not detail those steps, the computer will not know what to do. It's not like a human recipe for cooking something where the instructions are mostly general and the human can fill in the gaps. But with programming, it's different. So code usually runs sequentially. So first line, and then second line, third line, etc. So now that's the basic concept zero. But then the actual first concept we're going to talk about is variables and constants. So what is a variable and what is a constant? So a variable, you can imagine it as, first of all, your computer has memory. Imagine slots of where you can place data. A variable is you putting a sticker on it with a name, let's say my variable, and then storing into that cell. So imagine you have cells that could contain data in your computer. So it's basically a representation of your memory. And then you pick one of those boxes or those slots. You put a name on it to know, basically to be able to tell it apart from the other memory slots. And then you put data in it. So the type of data you can put inside of a variable are many. You can put numbers in JavaScript. So that's the number type, the data type. So you have data types. Those are called data types. For example, I would put 4 inside of the slots, of the slot my variable. And if I do this, and I again use the console.log message and pass in the name of the variable, my variable, it's going to print out the content of that. So if I look at the results, it's going to print 4 at the console, in the console. All right. Now, the way you declare a variable, so you create a variable, is you need to use the let keyword. So usually important keywords in JavaScript are in blue like that if you're using VS Code without any themes. But anyway, let is how you declare a variable. Once you have declared a variable, you can call it elsewhere. And you can even modify its content. So if I have my variable and put 5 instead, then console.log my variable, you can see the content is going to be different. If I go here, first it was 4 at line 2, and then when the computer arrives here, it modifies the content of the my variable, and then we console log again at line 4, and the content is now different. Okay, now there's a bunch of questions that you might have. Is why the name my variable? So here, when you declare a variable, you can basically choose whatever you want as the name. There are certain symbols that are not allowed. For example, you cannot use numbers to name a variable. So you'll have squiggly lines to tell you that it's not allowed. You cannot use dashes to name your variable. However, 8 letters from A to Z, you can actually use A0L. So you can use numbers, I think, within mixed in with letters, but usually I prefer to keep my variables. Actually, can you actually do that? I almost never do this. So let's say Z0 as the name of the variable, and then here, and then, so I'm just going to remove it and see if it works. It should work, but I'm just making sure. Yeah. So basically there are certain names you cannot pick as well. You cannot call a variable let because this is a reserved keyword. So those reserved keyword in the JavaScript language cannot be used to declare variables. And as you saw, I wrote my variable. This is a convention that is used in JavaScript code, where when you name a variable, if you have multiple words that comprise this name, the name of that variable, then the first letter of the second word used in that variable name always start with a capital. So for example, just to show you, if I call my variable name, then I can just leave it like that. If I call it my name, I need to put the capital here. It's not the actual rules. That means if you don't respect this, the code will still run, but but it's against the convention, which is called camel case, because it looks like a camel, you know. So for example, my full name. So capital here, like it does a camel thing, camel hump. I guess that's the name in English for yeah, that animal, the thing behind. Anyway, so that's yep, that's how you declare variables. So now we saw that you could put numbers in it, but you can actually put text, a string of characters, as I said, strings we call them. Here I can put a name, for example, and then if you print that out, so be careful when you write your code to only put like defined variables, not random names. And then here, if I look at the result, you can have, like, you can see. All right, so now you know how to declare a variable, but you can do much more than that than just declaring variables. You can also declare constants. So a constant is like a variable, but the content of it will not change. And there is some nuance to it later on, but for now, just keep that in mind. So for example, I want to have as a constant, let's say the width of the screen, for example. I would call it screen width. Screen width. And then let's say 1080. This is a constant. It's if you don't want something to change, it means if I try to change the value, screen width, and then put something else, let's say 720, then if you look, let me remove that variable. If you look at the console, it's not going to let me. You're going to get an uncut type error, assignment to constant variable, which means that you're not allowed to change the content of a constant. Makes sense, right? So the general rule of thumb is that if you're if you're sure that you're not going to change, so by default, what I do is that I always declare everything as a constant, only when I know that I'm going to need to modify the content itself of the variable. So the default for me is const. I always use const unless I need to change the content of the variable, the slot, the cell. Then I used let to be able to do so. All right, hope this was clear. Now let's try to write something more useful. So let's say you have a constant called, okay, yeah, I have a constant called number1, and it's going to hold 5. By the way, when you see me adding a semicolon, this is something in JavaScript and even in Java where each time you finish a line of code, you write this after its statement, because there are some other types of constructs in programming that don't require the semicolon, but I usually prefer not to use it because most of it's not mandatory most of the time. So I usually do this, but you know, just so that you don't get confused, if you try to use other resources, I'm gonna from now on always write the semicolon when it's needed. So const number1, let's have a second constant, number2, let's say 4, and then you can do math. So let's have another constant, and then we can have number3, or we can call it result. And it's going to be number1 plus number2. So this is basic arithmetic, so it's an addition. And that means the result should contain the 9, basically. So if I do console log, and I want to print out the result, and then look at the result here, it's going to be 9. Now the other way, you can do multiplication. So to multiply in JavaScript, you use the star symbol, not an X symbol, but this one. So now this should be 20, and it is. And then you can divide here by using the slash. So those operations are the same as math, but the symbols used are different. So you might not be used to them. That's why I'm telling you that, like, which is which. Here, 1.25. And then I think here, No, that's yeah. For now, those are the basic operations. You can have exponents as well. So for exponents, you use this symbol. I don't know how it's called. So if I look at the result, 1. So wait a minute, that's not right. I think it's two dot like that. Yeah. That's how you do exponents. So if you have, let's say, 2 exponent 2 to the power of 2, it's 4. The operation that I just did, this is something different, and I think it's something different. Actually, I don't remember, but there's bitwise operations. But for now, I don't think it's really relevant for game dev in JavaScript for now. All right. Okay, so now you have seen as a first core concept how to declare variables and how to change the content of a variable, but you cannot do that for constants, and that you can put numbers and strings in them. Now, what happens if you have, let's say, a constant called text, and it has a string called hello world, and then you have a number, let's say 4, or number 1, I was going to say. Maybe just number, but I think number is a reserved keyword. Maybe it's not. And what happens if I want the result? So by the way, you don't have to store the result of the operation inside of a constant or variable. You can just do it within the parentheses here. So text plus number. This, in any other language with a sensible type system, this should fail. But in JavaScript, it doesn't. It actually tries to compute it, and here it will do something called concatenation. So it's going to concatenate 4 with hello world. What does concatenate means is that if you want to join text together, join 2 strings of character together, you usually use the plus sign for it. So that might be confusing because this is usually understood as adding something with something, but adding text with text, how does that work? So if I were to have hello world and then I would say hello world 2, you should have as the result in the console 1 single string with both of them. So this is how the concatenation operator, which uses the same symbol, is plus. Now, the reason I said that it should fail when a number and a string of character are added together is that it makes no sense. You need to first, for example, Python, you would first convert this into a character, and then you would concatenate it. But JavaScript doesn't have this thing, and it's something that it has been criticized a lot. So just keep that in mind, to be careful with those operations. So don't do that, or if you don't know what you're doing. So yeah, this is cool and all, but it's time to actually learn the second, I would say, or third core concept, which are conditional statements. And this is how like a program will truly like become alive in the sense that it's actually going to do very interesting things. So we have a few constructs we can use. The main one is the if statement. So an if statement allows you to have conditional code that will execute only in certain situations. For example, let's say I'm going to have a variable this time, and this variable is going to be called is true. It's just a name, or maybe I'm going to call it execute. One other type I forgot to mention is that you have something called a boolean type. So boolean can be either true or false. So here you could have a true statement. So true means that it is true. And the reason why the true and false thing is useful here is because it allows us to have conditional logic. Conditional logic is code that will execute only under certain circumstances or do something else otherwise. So here in the if statement, I can have the execute, pass in the execute variable. And now if execute is true, it's going to run what's within the brackets. So here I can have a console.log statement, console.log. And I could say hello. And now if I look at the execution, the result of the code, you can see hello here. All right. Now, the issue here is that let's have something more complex. So what if execute is false? First of all, you put false in. Nothing will happen. So nothing will happen. Nothing is happening. Now you can use this to have more complex code. So let's say let's create two constants. Let's say if the age, let's say 25, and the height is 182. So you could have an expression execute, and then instead of passing in a boolean directly, you could do if age is superior to or equal. Let's say I'm gonna teach you those symbols later on, but this is what we call boolean comparison expressions. I don't know if it's the actual term, I forgot, but anyway. So if the age is above 18, then it's gonna execute here. So you're an adult, for example. And then here, if you put some code outside, you're considered a minor. All right. So here you go. And now if I run the code, you can see though both of them has executed because the age here is actually above 18. So if you want to only run this and not this, you would use an extension called the else statement. The else statement, what it does is that if this condition is not true, it's going to run what's within. I mostly prefer not to use it, so I'm going to show you the alternative right after. So here we can see because the age constant was set to 25 manually at declaration. That's why you can modify. By the way, a constant, you can modify it manually here. What it prevents you to do is to modify it later on, like age, set to new age. Just make sure this is understood. So I said I would show you an alternative to using an else statement. What I prefer to do is to have, actually I cannot do it here, so I'll wait before showing you because there's another concept that you don't have yet, so you will not understand the trick. So basically for now, else if you don't want. So if you want to have more than one condition though, for example, if you are here an if, and then you can have an else if, and then else if you can pass in another condition and then have it here. So yep. So that's the proper syntax, and then you pass in the condition here. For example, here instead of putting this inside of a variable, which there is no need to it, it was just to show you, you can put the expression within the if statement, and it's usually what happens in actual code. So if age is superior to 18, or if age is equal to 18, equal, but to 18, and then you remove here so in certain situations, for example, the if statement, you don't add the semicolon thingy. So that's why I usually prefer not to use it, but anyway, I'm going to use it. So here you have first, if the age is above 18, so I'm going to remove this. This is no longer valid expression, JavaScript expression. So if the age is superior to 18, then it's going to print that. If age is equal to 18, you could have another message. Let's say console.log. You just turned into an adult legally. Let's go. And now, if I go here and modify the content, let's say 18, you're gonna see that you're gonna have a different message. And you can actually start making games like that where you would change depending on what the player does, you have different constants or variables, and then you show different things. But this is the basic of an if statement. Now here, equal, that might sound strange. So equal means that since in JavaScript we use the equal sign to declare a variable or store in it some value, we need a different symbol in order to compare if two things are equal. And the double equal is what's used, but actually that's not true. What's used is the triple equal, because in JavaScript, so in any other sane programming language, you would, for example, Python, you would have two equals to determine if something is equal to another. And this is an error I would do a lot. So by the way, when you start writing code, you need to be very careful that this symbol is to store something inside of a variable or a constant when you declare it. But the double equal is used to compare things. But in JavaScript specifically, you don't ever use this. Use the triple equal. Because the triple equal, the reason why we have a triple equal is that if you have the equal equal, and let's say instead I'm going to remove all of this and have an if statement and have age equal 18. So here, if this condition actually occurs, we're going to say, I don't know, something like ABC. It doesn't matter. So here, if we have this, that means you could have declared a string 18, and then this is actually going to be true and it's going to print out, even though this is a string and not a number. So if I go here, it's going to print out ABC. And this is problematic, because usually when you write this condition, you're expecting that age is a number. So that's why if you use the triple equal, which was added later on in JavaScript lifetime as it was developed, like years later, it's not going to print it out. So the default, I always use triple equal. So now if I put back a number, it's going to actually work. So what triple equal does, it makes sure that not only the values are the same, but the type is the same. So the type being either string, number, boolean, etc. are the same. So I go here, ABC is going to print out. All right. Now there's many different expressions. So when you use, for example, you cannot do this. Actually, yeah, you cannot do this. So when you're using above or equal, etc., you use single quotation marks. A single equal sign, sorry, with before it the either greater than symbol, lower than symbol, and also a new one that you might not be familiar with is the bang equal symbol. So bang equal means it's not equal, and it's if I go to here, so bang equal, the symbol is basically like this. You see in math classes where you have a, this symbol. Yeah, it's basically that, not equal. You can also have just greater than itself, and it means exactly what it means. Oops. Lower than, etc. Yep, and that's it. So that's all there is to it at the basic level. So just to summarize, here are all the symbols we've seen: lower or equal, greater or equal, greater, lower, not equal, equal, but equal stricter, or which is you prefer this over this. So forget even that this exists. All right, so that's that. Now there is so that's for conditional statements. There's another type of conditional statement called the switch statement. So the switch statement is this, and it takes in, for example, your age, and then it will match it against cases. I prefer to, so the cases must be specific. So for example, for case 18, you write some logic here, and then you need to break out by using the break keyword, etc. I think as a beginner, don't really think about it too much. You just use only if statements, and you should be fine for now. Later on at the end of the video, I'm gonna point you toward a great JavaScript resource for if you want to dive deeper. All right, now there's more complex types of data you can put inside of a constant or a variable. And those are arrays and objects. So let's start with arrays. So arrays, the way you declare them. So for example, I usually prefer to do const, and then let's say I have a bunch of numbers and I want to store them within a single constant. I'm going to use an array. The way you declare an array, the simplest way is to use brackets like that. And then for each slot, you're going to have an element. So 1, 2, 3, and then you separate them by commas. So this is how you declare a constant. You declare an array, sorry. So 1, 2, 3. This is my array. It contains the numbers 1, 2, and 3. You can have arrays where you can have one element, one number, and then a string, and a number again, etc. But let's keep it simple for now. So here we have an array. And one thing that is tricky is that you remember when I said that a constant means that you cannot modify this later on. That means you cannot later on in your code come here and then change with another array. For example, an array which is 1, 4, 6. It's not going to allow you to do that. However, you can actually change each each element itself, the content of each of the slots here. This might be tricky because constant, you might think that things must remain constant, but here the array itself is constant. It's just the content of the array that is changing. So the way you access specific elements of an array is that you take the name of the array that you determined, and then in the brackets you put in the index. So the way array works is that the first slot has an index of 0. The second slot has an index of 1. The third slot has an index of 2. And so that means that the first element is not, the first index does not start with 1, but with 0. So here, if I do numbers 0 and I print that out, you're going to have something here. So console.log and then numbers equals 0. If I look at it, the results, you can see 1. It's going to print out this one. If I do 1 as the index, not the element, the index of it's going to point toward 2. It's going to print out 2. And then if I do 2, it's going to be 3. So you need to like really keep in mind that these are the values, the elements of the array, and these are the indexes. So basically the address of each of those slots that contains 1, 2, and 3. So if you were to use names instead, just to drive the point home. So here we have an array of names. So I'm going to call it names. And then here you can have like, I don't know, John. Let's say, I don't have any ideas for names here. Max, maybe. And then Chris. Okay, you have 3 names. And then here, those are strings basically. And then if you console.log names at index 0, it's going to print you John. John. Same thing if you do 1 instead, it's going to print out Max, and so on and so forth. So Max here, etc. All right, so now that we have arrays, you know that you can have this. So if you were to, instead of putting a const, do let, you could be able to replace the whole array itself. So you could redeclare a variable like that. But here I'm putting an empty array. That means that when you're gonna console.log it to the console, it's going to be empty. It's going to print you an empty brackets. Yep, empty array. All right, so hope you understood that's how arrays work at the basic level. Now there are operations that are available on arrays. So for example, let's say you want to remove the last element of an array. What you can do is you do names.pop. This is a function or method. So I need to explain what a function is first. So you know what? Let's wait before teaching you that those operations. So now, you know what? Now I'm going to call them operations because anyway, console.log is a function that you call a method. But you might. So I'm just gonna for now call them operations. So there are certain operations you can have on arrays, and one of them in JavaScript is pop. which removes the last element. If I go here, you can see that we have John Max, but Chris is no longer there. We have push. If you want to add an element to an existing array, what you can do is use the push operation, and from within the parenthesis, you can pass in the next the element you want to add to that array. So here I could decide to add, let's say, Takuya. And now here, if I console.log that, names, the name, you can see the array is going to have now 1, 2, 3, 4 elements. You can get the length of an array by doing dot length. So this gives you the length of an array. This is all things, concepts to revise, by the way, because I don't think you're gonna remember them like that if you don't use them. All right, so another type of data type you can pass, in a constant or variable, is the object type. So here, let's say I have an object const my data. I'm going to call it this way. You can define an object by using brackets like that. I always forgot to put the semicolon here at the end. By the way, my editor will put it automatically for me. That's why it was always there anyway. Here, an object can be, think of like, it's where you can store properties of data. So I think the best way is just to show you an example. So you have key value pairs. You define a key that you want to use, and then the value that is going to be paired with it. So for example, let's say we have a name. You can decide on the key name. You can write it out like that without a string. However, if you want as a key to use something that is more than one word, let's say name2, you need to put this within bracket, how we say, quotation marks. So here, because we're not using them within, we're only using a default name, a single, no space name, we don't need that. And then you use the 2 dot, and then what comes to the right is the value. And here, what you can put here is the exact same you could put inside of a variable or a constant. It's the same type of data. So for example, the name, I could decide on John, for example. And then here you need to always put the comma. I think if you only have one element, you might not need it. But usually you'd use comma, and then you can add another thing. Age, let's say 25, 24, let's say. And then so on and so forth. And it's a handy way to store a lot of data. So age, nationality, for example, you could say America or US, USA, etc. So what's cool with those objects is that you can do my data. So to access it, you can do console.log. Either you can print out the whole thing using my data. So if I have the name of the object, so you're gonna have the age, the name, the nationality, or you can print out specific pieces here by using the dot notation. So dot, and then you can see the various properties. So the age, I just want to print out the age, you can have it here. One thing that is interesting with object is that you can declare new records or properties by using the dot notation itself. So I could decide on a new property after having declared my object. So here I would call it maybe height, let's say, and then put an equal sign, and then 182 maybe centimeters. Probably should put it in inch, so let's say 6 foot. So my data height 6 foot, and then maybe it should be a string here, so 6ft. So now if I print out the console by using console.log, the my data, you can see that a new record has been added. Let's see, a height. You can see that even though it's a constant, like with the arrays, it will let you add new properties from within the same array. What it will not allow you to do is replace the whole thing with a new object. So by doing my data, if you were to do this, then it will not allow you to do that. So this is how object works, and I would say arrays and objects are one of the most useful data structures that you're gonna use. There are others, of course. The reason I decided not to talk about them here is just not to overburden you with complex, and I'm really teaching you only the concepts you need to make like your simple game. And then as you gonna get deeper, you're gonna probably search and then find new features, new data structures you can use, etc. All right, so now that you have this key value pairs, etc., there's another way, actually, I forgot to mention, that you can access properties from an object. You can do my data and then pass in a bracket notation that is similar to what you saw with array, but instead of passing in a number, which is the index, you can pass the name of the property as a string. It needs to be a string here. So this is especially useful when you have a property that is 2 words, for example. So for example, nice, I don't know. I don't have any idea what to do here. Let's say years of experience, years of XP. And then let's say 2 years. And then here you cannot access this by using the dot notation. Maybe you could actually. Yeah, you cannot. It's going to transfer. You're going to transform the operation to the array notation. I don't know what is the name of it, but this is the other way of accessing a specific property, and is mandatory when you have a property that is a string in string form with more than 1 word. So you can actually use that way of accessing properties with the other ones by just passing it as a string instead, age, and then name, etc. So I hope that was clear. So the next concept I would say that is pretty crucial to understand is loops. So loops allows you to repeat a same line of code or multiple lines of code multiple times. This is very useful because it will allow you to repeat stuff and generalize. So you don't have to repeat yourself. For example, if I want to print 100 numbers, I'm not gonna write console.log 1, console.log 2, 3, 4, 5, 100 times. That would take me forever. And this is where for loops come into handy. So for loops are defined like this. So for something, so for an expression, a condition, do what's inside here. So for, let's say, this is where for let I equal 0, I inferior to 100, I plus plus. Okay, this might be strange, and I'm going to explain it. So we declare a variable that is going to act as a counter. The convention is usually to use a single letter, like I or J or something like that. And then it's going to contain, so the for loop contains 3 expressions. The first one is the declaration of that counter. The second one is the condition to look for. So for I inferior to 100, so as long as I is inferior to 100, then it's going to run what's in there. And the third expression here is after running what's in there, it's going to increment, so add to the value of I by using the plus plus sign. So something I forgot to teach is that, let's say I have a variable called number1 and it contains 5. You can add to it by using number1 plus plus. That means the content of number1 is going to be 5. Another way you can do that is doing plus equal and then 1. That's another way of doing it. You can also do minus equal 1 or multiply equal 1 if you want to multiply, etc. The long form of that is to do the content of number1 plus 1. That's the most verbose way of doing it. So just something I forgot to teach you. All right, so here, so if I have let I equal 0, okay, so let's write something here. So console.log, and I'm just gonna log the actual counter itself. So here, if I go here, you can see that it's going to run from 0 to 99. So 0 because the counter was started at 0, and 99 because, if I were to do 1 instead here, it's going to still run till 99, but starting from 1. If you want to print out numbers from 1 to 100, you need to change this. Instead of it being inferior, you need to be inferior or equal. So if I go here, you have up to 100. So, yep, this is it. So this is the basic traditional way form of the for loop. And now considering one thing, let's say you remember we had an array. So let's say we have an array of names and you want to print out each name individually. So I have John, Max, Chris, and we want to print each of them using a for loop. So how would you do that? The basic way to do is to have index I, the counter, to 0. And down here, we just make sure that the index, the counter, is going to be inferior to names.length. If you remember, by using the dot length, you're going to get the length of an array. And here the length of an array is 3 because there's 3 elements. So here in the console.log, I can do names, and then if you remember, you can pass in the index here. So since it starts at 0 and it's going to be inferior to the length, that means it's going to be 0, 1, and 2 maximum. So if I do here, and you can have John, Max, and Chris, that is going to appear on the screen. So in the console, sorry. So just to illustrate what is happening, is that if I take this, for example, yep. So okay, I'm just gonna copy that code. I'm gonna go to the board here. I'm gonna paste it here, and let's zoom in. So what happens here is I'm gonna use the pen here. So we had 3 elements. Maybe I should increase the font size. XL. Here we go. So here, okay. So if you remember, we had those 3 names inside of the array, and the for loop, what it does, it's just going to, if I do the execution, I is first going to be equal to 0. So during that first pass, names, that I is going to be basically equal to names with 0. And if you remember, the index 0 is the first index of the array because we have 1 and 2. So if we have I afterwards, I equal 1, names is going to be, sorry for my poor handwriting, 1 here. So that means name is going to be 1, and it's going to print out Max. So the first time it prints John, sorry. The second time it prints Max. The third time, I is going to be equal to 2. And here, so what happens is that I is equal to 0, we print out John, and then I++ will make I equal now to 1. And then here, I is going to be equal to 1. I'm going to print out Max. Here, John. And then I++ is going to come into play, which is here, remember? And that means I is now equal to 2. And then here I is equal to 2. That means names square bracket 2 is going to point towards the Chris name. So Chris is going to be what's printed out. And I++ is going to make I equal to 3. And now we have I equal to 3 here. And if you remember, we run this as long as I is inferior to names.length. And names.length means that the array names has a length of 3 elements. That means that this condition is no longer true. That means we will not run the for loop another time because I inferior to names dot length, which is the array, is now false, equal to false. So hope that little schematic drawing was clear. Alright, so that's how a for loop works. And now there is a easier version of the for loop that doesn't, where you don't need to think like that. This for loop is still useful in certain situations, but the easier version of the for loop is just to do here. So const name of names, and then you can just print out each of the names from that array. And then if I look here at the result, you can see that everything was printed out. Now this might be confusing because where does name comes from? So here the easiest version of the for loop is that you create a constant called name, but it doesn't have to be name. It can be any name here. This is just a convention because it makes more sense, because in the names array, what you have for each element is a name. So you do const the name of your variable that you just created of, and then the array. And each element is going to be assigned to that constant, and then you can refer to it from within the for loop. All right, so now that we have the for loop, there's another loop that is very useful. It's called the while loop. The while loop, what it does, it continuously prints, run the code within if the condition is true, as long as the condition is true. Now it's equivalent, I think, to a for loop where you just do empty expression here, empty expression. I'm actually not sure if you can actually do that in JavaScript. So this will run infinitely because it does it actually run infinitely? So let me test it out. I barely ever use this, so I'm gonna do this. By the way, something I'm just gonna teach you right now is if you want to, just for testing, want to blank out prevent certain codes from executed, can do Control Shift, and it's going to turn it into a comment. Later on, I'm going to teach you like what's the utility of comments, but comments are things that are ignored by the compiler, so you don't so they're not treated as code. So basically, it's a way to add notes explaining why things are the way they are in the code, but you should not overdo it. But this is the utility, and you can use it to blank out certain parts of the code you don't want to execute, just for testing purposes, for example. So if I do console.log test, just to test what happens, nothing happens. So nothing prints out. Or maybe, yeah, it's going to actually crash the browser. So if I do this, I need to be careful. I don't want to crash it. And I think it crashed the browser. I'm just gonna close it and crash the web page, not the browser. But so if I do this, oops. All right. Okay, so it runs infinitely. So if I, just to show you how the while loop is just a for loop, is if I have a condition, let's say we have let I equal 0, so like a for loop basically, and then as long as I is inferior to names.length, so I'm going to put back, so I'm going to remove it here, I'm going to put back the constant. So as long as name is inferior to length, what I'm going to do is I'm going to console.log the names dot with the index, so the actual specific element, and I'm going to increment the counter. So if I do this, you can see that it gives you the exact same result as if you were to use the for loop. Now, one thing I just want to show you is that if I were to do the same with a for loop instead, so here I'm going to comment out this one. I'm going to, by the way, hit Control Save frequently and VS Code to update what's on the code editor. Forgot to update what the code that is going to actually be executed, because live server, what it does is that every time you save, it's going to refresh the page and your local host, local server. So here, if I, instead of a while, I use a for loop, And here I use the empty thing, so the expression, I don't define it here. I also don't define the other expression. I think it should actually work the exact same way as a while loop, and it does. All right. So just to show it, but usually we don't use a for loop like that. Looks kind of weird, but we usually prefer to use a while loop. But I think Golang is another programming language that doesn't have a dedicated while loop. They just use the for loop in the way I've shown you. I'm not sure about it though. I think it's that. Anyway, so that's how a while loop works. Usually for specific conditions, you want to check, you want to run the condition as long as the condition is false, is true or false. You want to run what's in the while loop. It's not usually used to iterate through an array. For example, this is the terminology. It's called iterate through, when you want to go through an array and get every element. So for example, you can make a calculation here. If the calculation is successful, then you change the a variable from true to false, and then it stops running. So that's the use case for a while loop. But for now, you're gonna see when we're gonna make our games, there's a lot of JavaScript features we're not gonna use, and certain others that we're gonna use a lot. But I think it's a pretty important construct, so that's why I wanted to teach you that. All right, I think one of the most important concepts is the concept of the function. So a function is very important because it's actually what allows you to have reusable logic, reusable code that you can, instead of copy pasting your code everywhere, you usually create a function by using the function keyword. And then what the function keyword does is, first it's to declare a function, and then you need to decide on a name. So here the name I'm going to decide on is going to be, I don't know, add. Let's call the function add or addition, or maybe, you know what, let's call it add. And it's going to be used to add two numbers. So this is the basic function. So the function here, what you can use it, the reason it's so powerful is that you can see it as a template. So you can use a template, you pass in data here, and then you put it inside of your logic, and then you can adapt your logic to what you need. So here we need a function that allows you to add any two numbers, any of them. So here, the parenthesis here is useful because it's where we define the params. Params are parameters that the function will accept, and basically you can think of it as like tweaking values. So you can pass values to the function to adapt it to your situation. So here, let's say we have number 1 as our first param. So the way you define a param when you declare a function is by just deciding on a name. And then here I decided to call it number 1, and then comma separated by the second param you want to use. A function can have no params, or you can have one param, two param, etc. So it's up to you. Here in our situation, we want to be able to add two numbers. That's why I first take the first number and then the second number. And then here, a function usually can either return nothing, or you can return a value. So here I'm just going to not return anything, but I'm going to console log. So I'm going to print out to the console the result, which is number 1 plus number 2. Now here you need to be careful because you could pass a string here. It's up to you to be careful. If you were to use a typed programming language, that would be different because you would have to specify the type. So for example, if you were to use TypeScript, you would specify that this should be a type number and the other one as well. So just keep in mind that when you're using a dynamic language, a language that doesn't enforce typing like JavaScript is, you need to be careful what you pass to your functions or what operations you do. So there's a difference between defining a function, which uses the function keyword, and calling that function. So calling the function is what actually executes that function. Defining it, it's like a variable. Like you have the variable, you can define it where you define the value, and then you can call it, not call it, but look at the content of it or modify it by using equal signs, just the name without the keyword that comes before. So here for the function, I declare the function, and then I can call it using add, and then passing 1 and 2, or 3, 1 and 2. And what should print out to the console is the result 3. Now, one thing you need to keep in mind is that while execution of code is sequential. So you have 1, 2, 3, 4, 5, 6, etc. It's step by step. Functions can be declared in any order. That means that it doesn't matter if I call the function before it is declared. I think this should still work. So if I look at it, it's going to still give you the answer. The reason for this is because the way JavaScript code is executed is that it first parses your code and is going to first look at the various functions you have and parse them. So it's going to basically register them that they exist. So that's why it does not matter the order of when you call that function. So I can call it before it is declared, because the way functions are parsed is not sequential. But it's the code that is executed sequentially. Hope that distinction is clear. But usually I prefer, to first declare the function and then use it, rather than, do this. So now that we have that, I need to talk about return statements. So as I said, a function can return something or nothing. Here, if instead of console.logging the result, I want to return it, I can do return, and it's going to return the value. So what does returning mean? That means it's going to just give you the value. So for example, if I just call the function here now, nothing's going to happen in the console because nothing is visible. However, you can do console.log and then call the function from within that console.log, and then you're going to have the result, not a number. That's not because I didn't pass the params we need, so 1 and 2. So doing this is going to give us the result. Now, why would you return here is that it's not often the case that you want to actually, console log immediately. You might, for example, want to have a constant result here. Call the add function, let's say 1 plus 2, and then with the result, you want to have another call to the add function with the previous result plus, let's say, 2 or 3 again, and then you want to print out the final result. So this is a use case, a very contrived use case, but it's a use case nonetheless. So that's it. That's how you declare a function, how you declare params, etc. That's the basics of it. Now, another very important part, another concept I would say is extremely important, is that we need to know how things are passed to the function. So there's something in programming called passing by reference or passing by value. So passing by reference is when, let's say I declare a constant number 1 outside called 5. I declare another called let's say 4, number 4. When I call add here, let's for the sake of argument, let's say you have a let here and then let here as well. If I pass in number 1 and number 2, and let's say instead here of just adding, what I do is I actually try to modify the content of number 1. If I do instead of number 1 here, it's going to be 6, and then number 2 is going to be it's going to be 5. When I'm going to print out console.log number 1 and console.log number 2, if you look at the results, you're going to have 5 and 4. Nothing has changed. So let's say even let's ignore even this. Let's say it's no longer called the add function. Let's call it modify. I'm going to attempt to modify these two variables. You cannot do that. And the reason for that is that what is passed to a function is by value. That means it takes the value of your variable or constant, and then it's going to create within that function a local variable called number 1 and number 2 in this case. That means even if I modify it from within the function, it's not going to impact what's from outside. Now this is tricky because in JavaScript, there are certain things that are passed by reference in a function. So by value is when you just pass the value. That means no matter what you do within the function, it's never going to modify the outside content, which is good. But in certain case, with arrays and objects, it's actually going to modify the content. So that's something very tricky. let's say we have a single param, which is going to be an array. I'm going to call it my array. And I'm going to remove this, and I'm going to remove all of this as well. So this function modify, let's say we're going to try to overwrite the array by putting it as an empty array. And then, yeah, it just does that. Now what I'm going to do here is I'm going to define an array called, I think if I use const here, like let's say my array, and let's say we have an array of 1, 2, 3. I think this actually might prevent us from doing this because we're using a constant. Anyway, if I call modify and pass in my array, because arrays and objects are passed by reference, if I console.log the array, it should be modify, unless because I use the constant, it's going to protect it against modification. So if I do this, let's see, 1, 2, 3, and you can see that nothing has changed. Okay, that's oh, never mind. That's not it's normal. When you pass the array itself, it's not gonna modify it. So you cannot modify the array. So the array is as if it were passed by value. You cannot override the array. The only tricky part, sorry if I confused you. So it's passed as if it were passed by value, but however, if you push, that means you add content to that array, let's say 121, it's going to modify the original array. That means that's why I say it's passed by reference. So if I go here, you can see that it added to the external array here. It added the number that was added from within the modify functions. That means that the my array here is not a copy. It's not a independent copy from the my array that is outside of the function. And this is tricky because if you're not careful, you might think that you're not modifying the array, but you're actually modifying the original array. So you might think that you're not modifying the original array, that it is safe, but it is not. And operations like push, pop, etc. modify the array, the content of the array, even outside, so that it's passed by reference. However, you cannot actually overwrite the array. So if I do this, it's not gonna propagate. So my array outside of the modify function is still going to be the same value. So it gives you a reference to it, but if you remove the content, it's not gonna propagate. So this is a tricky thing. So if you need to take an array from the outside and do a bunch of operations inside of a function, what I recommend that you do is you make a copy of that array. So either you can use the spread operator, etc. So the spread operator is something like that. So my array can do this. I think this should do the trick. Does it? Oh, from within an array. Like that. So it takes the content of the array and spreads its element inside of a new array. The 3 dot dot does that. So that's just something I wanted to mention. All right, so now you've learned about this nuance. You need to be careful here. I think that we've gone over the main, I would say, the bare bones concepts you need to learn JavaScript. There's two last concepts, I would say. The first one is a local versus global variable. So in functions, by using the functions, you probably like intuitively understood the concept. So if we have a function, let's say call it main, and you have a constant outside, John, for example. So if you have a name called John, you can have access to it from the inside of a function by printing name here. So here deprecated. Okay, so that's something with JavaScript. So let's say my name, just to be different, make sure that the name is unique. So okay, so we have here. So if I call the main function, for example, and look at the result, you can see John is printed out. That means that what's declared outside is accessible globally. That means it is accessible even from within functions that are declared near it or outside. So what that means is that if you declare a function here, const my name max, for example, then this variable, this constant, is not accessible from the outside. I cannot do console.log my name here. It's not gonna work if I remove this. So actually, just to test it out, it's going to print John but not Max. But from within the main function, it's going to print Max. So it takes the nearest value, the nearest declaration. So if I do this, you can see John Max. So this you need to be careful with this. If you want something to be globally accessible, you need to put it outside. If you want something local, you declare the variable, the constant from within the function. And this works the same with if statement, etc. So if you have an if statement, let's say I'm just gonna put it to true, that means it's going to run either way. If I declare a variable called age, and let's say 12, then console.log the age. This works, but if I want to console.log the age from outside, the if statement's not going to work. So if I do this, age is not defined. So hope you understood this, the difference between a local global variable and how scope works. So the concept itself is called scope, the scope of variables and constant. So yeah. So if you want something to be only accessible locally, you declare it as closely as possible as where you need it. So that's that. And then finally, there's the comments. So in your code, you can add comments by using the -- symbol and then writing your text. And usually comments are, you leave them for others and yourself to explain why things are the way they are and not what the code does, because what the code does, you can read it yourself. When you first start programming, it's very difficult for you to know what the code does. You really have to sit down, read line by line, etc. But as you become a more experienced programmer, you can actually it's pretty straightforward to read a piece of the code and understand what is happening. So useful comments are comments that explain why things are the way they are, not how it works. So why, for example, you had to use this resolution, so you had to declare const with 1000 something because this constraint, and we need to have this aspect ratio, etc., which is not clear to someone who would read the code. This is where adding a comment would be very useful. All right, that's it. I think we have the basics concept down, and then we can actually there's one last thing. It's not actually a JavaScript concept itself, but it's very important, is how to modularize your code. There are other concepts in JavaScript that I've purposely left unexplained and not in this course, just so to not make it too heavy for you as an introduction. But now this is something very important. Let's say you cannot, for small programs, you can write your code all in a single file. But as soon as you become more, your projects become more complex, it's going to become time to be able to split that into multiple different files. And the way to do that in JavaScript using this setup is simple. There's the old way and there's the new way. The old way is that if you want to use multiple files, the way you do that is, let's say I create another code file, and I would say, for example, utils.js, which is going to contain a few functions that allows certain operations, like say number 1, number 2. So this is going to return the sum between those two numbers. It's a reusable piece of code I want to use in my main.js. The way you would import it in the old way is you would go back to your HTML, you would add a script tag, source, and then the path towards that file. And then, don't forget the closing brackets. And then you would go into your main.js, and then you would be able to call that function with the rest numbers you want. So you would be able to use that function that is in the utils file from within your main.js file. So if I look at the result, you can see that it actually works. Now this is the old way, and this will quickly become very messy as you add a lot of script tags. This is not the way to go. Because recently, well, relatively recently, there is something called a JavaScript module. So JavaScript module, what it allows you to do is to use an import syntax. So instead of having your file here, you can just use the add function out of nowhere like that because you added the script tag before. And by the way, with this old way, the order of which you import your script tag is important, because if you import, I think, the script tag afterwards, so let's try it out just to make sure. If I do code utils, so let's say I import the utils, the add function after declaring, now it's not going to work. So here, if I look at the result, you can say add is not defined. So that was one of the very tricky things, is that you need to be careful of the order in which you import, you put your script tags. So that's really not the way to go, I think, today. So the way to go is to use the JavaScript module feature, which what happens is that you specify a type, the type attribute. And what you're telling the browser is that this type, the JS file is going to be of the type module. That means that you can use the new import syntax. So how does it work is the following. So I have in utils.js, I can add export, the export keyword, and then from the main.js, I can do import, and then using brackets add from utils, and you need to add .js. So utils here is the path where the function is defined. Now here it's within brackets if you just use the export, but if you use export default, that means the only thing exported, the named export is going to be add directly. So you're gonna do it like that. And now the add function is going to be available and it's gonna run. Now the export, unexpected token export, export default, why is it not working? Let me remove this. Let's see if it actually works. Utils does not provide an export name default. Wait a minute. So if I do this like that, okay. So if you do export, and then you need to put this within brackets. If I go to the results, it prints out, but unexpected token export, syntax error, utils.js. If I go here, okay, by the way, you need to remove this, otherwise you're going to get an error. So with this new method, you only need to import the entry point, which is the JS file, the main.js, your actual, this doesn't have to be called main.js, it's just the name. You decide on the entry point, and then you give it the type module when you're importing it to your HTML with the script tag, and then you can have access to the import syntax. So you can, in other JS files, you can do export function, etc., and then you can import with brackets. If you don't want brackets and import directly, you can have default, but I think you can only have one if you do this. So you might want to have a file where you have multiple functions you want to export individually. You can use the export keyword for them. So export function add, export function multiply, etc. But if you want to have only one, you can do a default, and you can mix. I think you can mix. So you can have a default, and then you can have export function test, let's say an empty function like that. And then that means here that while the add function is going to be empty, you can add it directly like that. So if I look at the result here, you can also do a comma and then have test as well as the other named export you can use. So if I go here, okay, I haven't used it, but yeah. So that's the way to go, I would say. All right, so now we're ready to start making games. So, and before that, it's time to just talk about what is a library, and I briefly covered it earlier on, sorry. So a library is code that is written by someone else that you can reuse in your own projects, which allows you to not have to reinvent the wheel. And a library I really like to use to make games is called Kaplay. By the way, that's the library. And I have a whole crash course that teaches you how to use it, all the functions, not all of them, but the main ones. And you have a playground where you can see examples, etc. So this is a really, really cool library to use to make games, which provides you with a bunch of things out of the box to make games. So let's use it and make a simple platformer. So here is where things are going to get different, is that for now, we have written our code using this setup where we create a localhost server, and then with just index and HTML, you can actually start working on your game. This is all fine, but this is not how modern web development is done. We used Node.js and the NPM package manager and a bunch of other flavors to write our web code. So I'm going to explain how to set up that as well. Now you could use kplay with just a script tag. The way you would do that is you simply go to, I think I need to go on the GitHub, or in the installing kplay, you have the installation guide. What you do is you could have this thing here. I copy that. And then you can basically have that here. And then, by the way, even I just need this first statement basically. So here I go. So the simplest way to import kplay is this. So I'm gonna just go back to our main here. I can go here. At the top, I can use the import statement using native modules. And it's going to import the kplay library, which is going to bring you this kplay name. And it's going to import it from this link, this URL, which hosts the library as a .mjs file, which is for module JavaScript file. So now that you have that, you can actually start making your game. So if I call the kplay function, which is provided by kplay, it's going to initialize a canvas on your web page. So canvas is an HTML element that allows you to work with graphics. And this is basically what you use for making games in JavaScript. So you have here the canvas. Now this setup is all fine. You can start working and making your games. I usually prefer to download the file at this link and then locally put it in my project and then import from that locally without having to rely on the link being up. Otherwise, if it goes down one day, your game will not work. But I want to try something different just to teach you. I want to actually do it the way web development is done in the modern way using Node.js. So Node.js is what you're going to need to install on your machine. It allows you to run JavaScript on the actual computer outside of the browser. Now we use Node.js because we can use NPM, a bunch of package managers that allows you to use a bunch of libraries, etc. But at the end of the day, our code is still going to run on the browser. It's just going to pass through Node.js. It's going to be compiled into JavaScript that can run on the web. So JavaScript that runs on the computer using Node.js and JavaScript that runs on the web are different. They're mostly the same, but they're different. And that's why you need a compile step where it compiles your JavaScript code that runs in Node.js and then compiles it to a JavaScript code that can run in the browser. So the reason we did this is because in the past, Node.js JavaScript implemented the JavaScript standard, I think, more in a more advanced way. So it implemented new features faster, I think. And if you wanted to have a nice development experience, you had to use Node.js to get that, and it would compile the code back to JavaScript that could be used on the browser, which was less advanced. So I think that's the gist of it. But for this, the only thing you need to understand is that we need Node.js, we need NPM, which comes with Node.js, and we need a bundler, which is going to actually do the work to compiling the JavaScript code that runs on Node.js into JavaScript code that runs in the browser. So this bundler is going to be called Vite, and it's very it's newish, and it's very now it's used everywhere, so it's very convenient to use. And then after I teach you how to make the platform, I'm going to actually teach you how to put it on itch.io or some other how to publish it on the web. And that would be the end of this crash course. All right, so now what I'm going to need you to do is to install Node.js. So there's plenty of learning materials and guides on how to do that. So I'm not going to do the installation process with you. So once you're done with it, come back. So here we go in our editor. I'm just going to remove everything that we've created so far. So here I'm going to delete everything permanently. And this is where I'm going to open up the terminal by sliding my cursor here. You could have sliding here. You're going to have the terminal like that. So now I'm going to remove this. I'm going to remove that. I'm going to remove this. So we're going to have only the terminal window here. My screen is big on purpose. I don't actually develop like that, but it's just for the video so that you can have a good view of things. So if you have Node.js installed, you need to do node -- version to see that you have actually Node.js installed. So here I have version 20.11. I think the actual most current version is 22.5.1, so I should probably update soon. Okay, long-term support. So I have the long-term support version. All right, so now what I'm going to do is that once you have Node.js installed, you have access to NPM as well. And you're also going to have access to NPM-based commands. So here I'm going to create the project. So I have the folder learn.js, which is the folder I was in all that time ago. And what I'm going to do, I'm going to do npm create vite at latest dot. So this command, npm create vite at latest dot, is a quick start command that is offered by the Vite bundler, which is what I've mentioned earlier on. And I use dot here, so it's going to use the latest version, so that's why it's at latest. You can specify specific version, but I prefer for this to use the latest version. Dot means that it's going to create everything from within the folder we're currently in. If you wanted to create it in its own folder, you would type in a name here that you want the folder to be. And then here, if I press enter, it's going to give me a few options. So select a framework, and then here we're going to go with vanilla. We're not going to use React, Preact, etc., which are web frameworks. So I'm going to press enter on the vanilla option using the arrow keys and then selecting the enter. And then between TypeScript and JavaScript, TypeScript is like JavaScript with types. It's becoming more ubiquitous, I guess, used professionally because it makes your code easier to reason about. We're going to use JavaScript for this project. So by the way, if you know JavaScript, it's going to be easier for you later on to learn TypeScript if you want to. So now that we have selected our JavaScript, we have a scaffold project. So we have a few folders, and I'm going to go over them. Here it tells you to run npm install. npm install is the general command to install all the dependencies that are listed in the package.json. And package.json is the actual file that is very important to understand because it defines your dependencies and the various commands you have access to. So here our package.json have a name, which is the name of the project, the version, you can decide it on which version, the type module. This allows us to have the import syntax using the JavaScript modules, the import from and export thing here, import from, etc. So package.json, the scripts we have access to is the dev script, which will run Vite. So typing npm run dev in the terminal will run Vite, which is the bundler we're using, which basically compiles our code from JavaScript that runs on Node.js in JavaScript that runs on the browser. Now we also have the build command here accessible to us, which allows us to build our project for the web. This is going to come in handy when we're going to actually build the project and publish it somewhere. And then Vite preview previews the build. So dev is when in development. Preview is when you have built the project and want to see if everything works correctly. And then dev dependencies is the Vite bundler tool here. So here, there's not really much to do except like we need to do npm install. So let's do that. npm install in our terminal. It's going to install the dependencies, the dev dependencies probably, yeah. And it's going to add a node underscore modules folder. This node underscore modules is actually where the code for the various libraries you're using is going to be stored. Usually you have a .git ignore that ignores that folder. So Git is another thing you need to learn about. I'm going to leave this for another video, but Git is very handy when you're working on projects. you push them to GitHub, for example. You can have branches, commits, etc. Allows you to track your development, etc. very nicely. I'm not gonna touch the file today. I'm not gonna explain what Git is today, but I recommend watching a video on Git. I think you are watching a video or reading about it. It's very useful. Okay, so package.lock.json is not really important, but it contains the versions of each of our modules, etc. But package.json, if you have a project, someone gives you a Node.js project and it has a package.json, it's going to be very straightforward. You just npm install, it's going to list the dependencies, etc. So that's really great. Now here we have an index.html with a bunch of HTML that is irrelevant to our project. What I'm going to do is I'm going to remove everything. I'm going to remove everything. I'm going to put back HTML and the body tag. By the way, if you want to go more into web development, I would recommend learning HTML and CSS as well, more in depth. Here are the script tag. We're going to use the exact same code structure. I'm also going to remove javascript.svg, which is just a logo. I'm going to remove style.css. I'm going to remove counter. All of these are not necessary for a project. We have public. As for the public folder, I'm going to keep it. This is where you put your assets. But actually, it's not necessary for this project. I think we're going to do without. But let's keep it for now. So what I'm going to do is in index.html, at the same level, I'm going to create a folder. I'm going to call it code, like I did. Here, I'm going to create our main.js file. I should have probably just drag and drop, but because we're not going to use any of the code, I'm just going to delete that one. In index.html, I'm going to use the source as code/main.js, and then as the path. And don't forget to actually set the type for this as a module. And then here, actually, I don't think you need that. Let me just look at what was there previously. The original, yeah, it was there, so never mind. So like we did in our simple setup, we're going to do the exact same thing here. Now you might be wondering, like, why should I use NPM? Well, actually, you don't have to. The reason you would use it is maybe you want one of the advantage of using it in bundler that you can do with NPM is that you're going to be able to have your code minified into a single file, which is going to make it load faster in the browser. That's one of the main advantages. But otherwise, and also is going to make your code less readable to someone who wants to copy you. But even then, minifying code is not really a good security measure to protect your code from reverse engineering, because since your code is in the user's browser, there's nothing pretty much you can do. Now, if you want to make a paid game, I would just recommend, wrapping it as a desktop app, and I think you have more security features. But anyway, I think if anyone sufficiently motivated to reverse engineer you is going to do it, is going to be able to do it. But it shouldn't be a showstopper, I would say. For example, there are many games where you have access to this full source code. For example, Balatro is a game made in Lua with Love2D. And I saw a video on YouTube. I think it was from the channel Games from Scratch, where he showed how you could access easily the source code, because if you use Love2D, which is the framework for making games with Lua, your code isn't really protected. Because the way you get the executable is just you zip your source code and you do something that transforms into .exe, and then you can just open it back up as a zip or something like that. So you could see the whole code of the game, but it did not prevent Balatro from becoming a very big success in the gaming world. So that's something to keep in mind. So here I'm just going to add the type module as I did earlier on. Module. Here we go. Here we go. So now we have everything. We're set up. Now it's time to install the Kplay library. So Kplay is the library for making games. It was this one. And for the game we're going to actually make, let's do the exact same thing here. So here they show you how to do a basic platformer in less than 30 lines of code. So let's see. So let's actually copy that code. I think we still need on-key press. Yes, so it's going to be mostly in jumping mechanic. We're probably going to expand a bit on that, but yeah, that would be a good first try with Kplay, which is the library. And then for more in-depth content regarding this, you will be well served on my channel. I have plenty of other tutorials. By the way, you don't have to use Kplay. There are many other libraries like Phaser. By the way, if you want to use Phaser, you need to learn a bit more about object-oriented programming, something I did not mention a lot in this tutorial, in this course. You can use also P5 for making creative coding stuff. Very good. And I used P5 to make this game. By the way, you can watch a tutorial I made on the channel on how to build this exact game with P5.js. So that's just to tell you that there are many other options, and it's not just that one. I'm not paid to make videos on Kplay. So yeah, it's just a library I really like, and that's why I've been using it a lot. All right, so now let's install our library. So to install Kplay, you do npm install Kplay. That's it. And then it's going to install it, and it's going to add it to your package.json. Here you can see in the dependencies section, it's going to add version 3001.0.0 alpha 19.1. So this is the latest version of the Kplay library. Now, if you want to pin it to a specific version, by the way, if someone else use your project and just do npm install, it's going to install the correct version. Now, let's say you are watching this far into the future. You would do npm install Kplay and then a specific @ with 3000.0.0 dash alpha 19.1. If you do that, you're gonna have the exact same version. Now, nothing's gonna change because it's already the version, but in case you're watching this far enough into the future, you can use that to have the exact same thing as me. So that's that. All right, so now we have Kplay installed, and we can go to main.js and write import Kplay from Kplay. Kplay like that. So when you use Node.js, you use the name of the library in strings, not the path of the library, like we did with the other setup. So now if I do Kplay, call the Kplay function, one nice thing about using Node.js and Vite, etc., is that you have access to documentation when you hover over things like that you don't have when you use the other setup I had. So that's one reason to use it. So we have Kplay, which is going to initialize our canvas. So if I go here, go to the output, refresh. Okay, relative must be okay. Doesn't work for some reason. Import. Whoops. Oh, okay, I know why. Sorry. Everything we wrote is fine. The issue is just that now that we are using the other setup, this is no longer relevant. What we need to start our local development server is that you don't need the live server anymore. So you can click on the go live button that was previously, and then it's going to disable the local host. But to run a server when you're using npm with Vite is you do npm run dev. Once you do that, it's going to start the server, gives you the address. I'm just going to copy it and paste it into my browser. As for you, you can just click on it with control click, and it's going to bring you to the thing here. Here you're going to get an error called favicon. So favicon icon usually on HTML pages, you need to define an icon on top. Because we're making games, this is not necessary. And if you were to host a game on itch.io, it's even more not necessary. I'm going to teach you how to prepare your game for itch.io. I'm probably not going to go into the itch.io thing, portal, etc., and do the steps, but it will just involve zipping your code base, zipping the build output, and then dropping it on itch.io. That's it. So we have a canvas that takes the whole screen and space, so that's great. Now let's look at the code here. So I'm going to copy it, and I'm going to go over it. So and I'm going to explain everything. So we don't need this. You can use load bean. I'm going to explain why in an instant. So if I look, you can jump, you see? And now what you can do is you can bring forward squares, rectangles, etc. that are going to act as obstacles. Now, the way I'm going to go about it is I'm going to keep that code. You know what? Just it might be confusing for you, so I'm just going to write everything manually. So couplet is a method. No, actually, is the constructor, the way to initialize the canvas in. So the canvas element is what is used to make graphics appear on a web page. I prefer to hold it into a constant called k, because it's going to hold all the what we call methods. So methods are functions that you can call from an object. So remember, I talked about the fact that you could create objects, for example, my object, and you could have properties. And you know what? I forgot to mention, but you can have a property that is a function. So for example, you could have decided to have a function called, let's say, add, and you define it within like that. You can define it either like that or like that with using the arrow function, which is another way to declare a function. Just to not confuse you, this I think is the better way. So having this like that is basically a method. A method, that means you can it's a function that this object can call. So yeah, so that's a method. So that means that later on you could do my object and then dot call the function like that. So yeah, it might not be very straightforward, but that's how it works. So here what I'm doing is I'm creating the couplet canvas, and I'm storing the context. It's called the context inside this k constant. That means that from now on, for all methods that come from couplet, you can do k dot and then the name of that method. How I know those methods is that you need to look at the documentation. So when a developer creates a library, they have an API, a way of using it. So an API stands for Application Programming Interface, and it's how to use what the various functions and methods are available written by the library author that you can use in your own project. So what you're going to do here is there are a bunch of methods and functions you can use, and they're documented inside of the documentation in the docs section here. You have the various names of reference docs, and you have the name of the various things. Now for this tutorial, you don't need to look at that. We're going to just do a simple game. I just want you to have a quick win, basically, to have something at the end of this tutorial. And then later on, you can watch my couplet crash course where I teach you more stuff in detail, or you can watch my other tutorials. So what I'm going to do is I'm going to do a very simple game where you're going to play a character and it's going to jump over obstacles that come from the right. So think the dino game, and the Google Chrome dino game when you don't have internet connection. So to do that I'm going to first pass in an object as a param to the couplet method. Why this is just the way that this library works, and it takes in properties that you can pass. So if you pass in an object with the following properties, couplet is going to do something for you. So if I pass the width property and specify a width of 1280, it's going to make the canvas, so the screen where the game is displayed, a width of 12,080. Yeah, 1,200, yeah, and 80. So now if I specify the height as 720, we're gonna have a basic resolution. So yeah, just remove that so the code works. Now if I go here, you can have our canvas here. I'm gonna keep it like that so that you can see the whole game in my screen like that. Now there's a bunch of other options you could have passed, but I'm gonna not explain them here. So here, to load assets in couplet, you use a load sprite function, but there is a default called load bean, which is a default sprite that is available, which is the bean character you saw in the homepage of couplet, which is this guy. So instead of worrying about finding assets online, etc. I'm just going to use that for this project. So it's going to be easy to follow along. So now I'm going to create a game object, which is going to be our player. So a game object is an entity in Coplay that takes in that is created by using the add method of the Coplay context, and it takes in an array of components. Those components are offered by Coplay itself. That's why you need to use k dot and then you call them. So here, yeah, so k, and then using the sprite component, I can display a specific sprite. Since I called the load bean method offered by Coplay, I can call the bean sprite. So bean can be called with this by passing a string to the sprite component with the string being bean. That's how now, if I look at the screen, the result, you're going to see a bean appear at the top left corner. Now, let's say we want our bean character to be at the center. So Coplay offers a way to change the position of a game object you create by using the pause component. So all this knowledge that comes from k dot etc. k dot, it's not from JavaScript, it's from the library. So there's something to keep in mind. The separation between what comes from the library and what are concepts from JavaScript is important. So here you can use the k.pause component and then pass in either the width, the x coordinate or the y coordinate, or you can call the center method from Coplay for it to center the to give you the position of the center, basically. So here, if I go, you can see that the character is at the center. And by the way, if you press F1, the F1 key, you're gonna have the debug mode from Coplay, which you can see like various things, but it's not very important for now. Just remember that if you're using Edge, if you press F1, it's going to open the support Microsoft thingy, which is not something we want, but you can rebind it by using, I forgot actually, so yeah, I'm going to leave it for now like that. So now we have 3 components. So if I'm just going to display this in a more readable fashion. So we have 2 components being used, not 3. And as I said, the fact that this is an array of elements, this is JavaScript. However, sprite, pause, center, etc. are from Coplay. So these components, when composed together, gives us our player game object. Now we're going to use the area component, which is going to create a hitbox for our player. A hitbox can be seen as a square by default that represents the body of our character. What is going to be susceptible to collisions. So if I press F1 again, even though it will open, it's going to create a box here, which is useful because Coplay is going to offer us methods we can use and functions we can use for colliding. So by the way, every time I say method, just put in your mind that it's a function, basically. Okay, so now we have this, and then you can create a body. Oops. We're going to use the body component. So now what this is it's a bit not handy. So my code formatter does this. After 5 components or so, it's going to put them like this, so it's going to be more readable. But anyway, I use the body component from Coplay, which is going to make our game object susceptible to gravity and collision. To gravity and collisions as well. So now we have, if you just add this like that, and actually not to gravity, just to collisions, but to have our player affected by gravity, you need to use the set gravity method. And here I'm going to put a gravity of 1000. So now if we look at the result, our bean character is falling down. So we need to create a platform for the character to land on. So what I'm going to do is, you don't have to store your game object that you create in a constant if you're not going to use that later on, if you're not going to call it later on. So what I'm going to do, I'm going to just call the add method directly, pass in an array of components. I'm going to use the rectangular component to just create a rectangle, and this rectangle is going to have the width of the screen. So I'm going to use k.width, which is a method from kplay that allows us to get the width of the screen. I'm going to have a height though of let's say I think 200 or 300 should be okay. So now if I look at the result, you can see it's up there. Now I'm going to change the position k.pause, and I'm going to put it at 1 0 and then maybe 300. Maybe it's correct coordinates. So by the way, in game dev, the farther you go down, the higher the value of y. So that's something very strange if you're used to the higher the value of y, the more up you should go. So that's something you should keep in mind. So here, k.pause 0 300, I'm going to put it at 500. And then I'm also going to add an area component for the same reason as I did. Now this is not really handy, like you cannot barely not see the whole thing, so I'm just gonna reduce the font size a bit. Maybe, you know what, I'm just gonna keep it increase just so you can see and making sure that you can actually see. So k.area and then k.body are two components we're gonna add. Whoops, did it add it? No. Okay. So now the only difference here is that in our array, we're going to have to pass an object and specify the is static property to being true. So what this is that the body, okay, you see, now it properly formats it. So what happens here is that kplay has the body component, which takes in an object, and the object you pass in can define the is static property. And is static, if you set it to true, what will happen is it's going to make your platform, your game object, not susceptible to gravity. So it's ideal for platforms. So if I go here, you see it lands perfectly. Now I'm going to add an outline to the platform, and you can do so with the outline component and specify a thickness. Here is the thickness of 3, should be okay. And you land on the platform. All right, so that's all good and all. Now let's implement the jumping mechanic for a player. So you can do this here. So you can have player, and then here you can have an on-key press. On-key press is a method offered by kplay that is also available when you create on the resulting game object that you create. So on-key press takes in as the first param the key you want to listen on, and it's going to be the space key. I decided that. So when you press the space key, you can it's going to run the function that is passed as a second param. So here, because I didn't teach you the arrow function, the arrow form, this is another way to write a function. Because I didn't teach you that, what I'm going to do is I'm just going to define the function from within here. So you define a function here. Let's say, actually, never mind. When you want to just have a throwaway function, you don't want to spend time on naming it, etc., you can use the arrow function. So an arrow function can be defined like this. You pass in, you have the parentheses, and then you have an equal sign, and then a greater than sign, which gives an arrow, and then you have brackets here. So if you want to define an arrow function outside, you would store it inside of a constant or a variable, usually a constant, give it a name, and then do like that. So that's another way to define a function. There is a nuance to the difference between using the function keyword, meaning declaring a function like this with the keyword, and using the arrow function, but I think for now, just consider them the same for now. Later on, I'm going to point you toward a great JavaScript resource that you can use to deepen your knowledge regarding that. So here what happens is that when the space key is pressed, which was passed as the first param, the onKey press method is going to run the second function. It's going to run the function passed as the second param. By the way, you can pass functions as param to other functions. So you can not only pass in numbers, arrays, objects, strings, boolean, etc. You can also pass in functions, which is pretty handy. All right, so now what I'm going to do is write the logic. So I can just call the player from outside. Remember the global versus local thing. Because player is outside of the function definition, we can actually use it from the inside. So player dot, and then you can use the jump method from kplay, which is offered when you create a game object with, I think, the body component. So now if I go back to the game and I press space, you can jump. Now you can see that you can jump infinitely, because we need to actually make sure that the player can only jump when the player is grounded. Otherwise, they can just fly off like that, which is not what we want. So what we're going to do here is we're going to have an if statement. So this is where it's going to come in handy. So this if statement, by the way, if you have an if statement that the logic you want to run within the if statement is only one line, you don't have to have the brackets like that. You can actually just, do this, put everything on one line like that. So I'm going to do that. So if the player is grounded, this is a method offered by kplay that tells you if the player is grounded. What it returns is a boolean value. It says written here, boolean. That means it's going to return either true or false. And if you remember, this is exactly what we want in an if statement, because if this is true, then this runs. If it's not true, then this will not run. So if I go back, I will only be able to jump while I'm grounded. So now the only thing left is to have obstacles coming from the right, and then as soon as there's collisions, we are going to basically enter a game over state. So here we go. Now what I'm going to do is I'm going to have a loop function. So actually we can use a k.loop, I think that's the name. So the loop function is something from kplay. So the first param is how many seconds. So every 1 second, it's going to fire the function passed as a second param. So by the way, if you have any questions, things you don't understand, feel free to ask them in the comments section. I think I've tried to teach programming in a few hours to someone probably who had never written a line of code in their lives. So if you're in this case, you might still be confused because we're doing a lot. We're speed running through a lot of concepts. So you still need to practice those basic core concepts that I've taught you, but now you actually have a base from which to further your knowledge. So that's something you know what you don't know. Basically, you know where to look for information, etc. You know what terms to use in your Google search. So that's something pretty cool, as that is going to help you a lot. So here the loop, every 1 second, we're going to spawn a game object that we're going to create here. That is going to be a rectangle, let's say 50 by 50. Oops. Using the rect component is going to have a position of, I don't know what the position would be. Let's say, what happens if we go 200 by 200? I'm just going to see it. Okay, it's going to put you here. So if we increase the value of x, we're going to have, let's say, 8,000 and even more, 1,000. And then here we're going to go down. So we need to increase the value of y, if you remember why. Because the higher you go in values of y, the lower you get. Okay, so here I see it here, it's a bit too low. And by the way, I'm going to add the area component. I'm going to add the body component. And I'm going to add the outline component. By the way, the order of the components does not matter in couplet, and you're using the couplet library. So here we go. And now what I'm going to do, yeah, so it's increasing in place, which is not what we want, but it's a pretty cool effect. That's really nice. It's unintended, but really cool. So what I'm going to do is, after having this, I'm going to actually have a move. The move component is you just determine the direction. So the direction at what speed. So the first param, I think it's the direction. So you use a vector2. So vector2 is just an x and y value. It's a data structure offered by Kepler, and it's very useful for specifying coordinates, etc. So here the vector2 is just going to be, let's say, 1, 0. And then the speed. Do you need to specify the speed? Yeah, the speed is the second param. I'm going to explain why 1, 0 in an instant. Here the speed, let's move at 300 speed. Let's see. Now it's more. It's better formatted. I think I better like this for format. Unfortunately, it only gets to this point after a while by my formatter, which does it yeah, automatically. Okay, so here the vector2 is used as a direction, so the x direction and then the y direction. So the x direction, that means it's going to move in the direction of x1 means to the right. So if I want this to move to the left, it needs to be -1. For the y-axis, we don't need to move in any direction. And then it multiplies this by the speed, which is 300. Here we go. So we have now our jump is a bit floaty. So maybe if we did the game as, instead of dying as soon as you get hit, what if the game was you have those blocks appearing, and the goal is to survive and not be pushed outside of the bounds of the thing. It's going to be a nice twist on the dino game. So here I'm going to reduce the gravity to maybe 800. So I've reduced the gravity. It's still a bit too floaty to my taste. Maybe I should increase the gravity, not reduce it. Let's put 1,000 or 2,000, let's say. Let's say 2,000 should be a good value. All right. Yep. 2,000 is nice. Now we could, have a speed that varies. So let's do that. So let's have a couple of different speeds the boxes can move towards. So here I'm going to define an array. Oops. Const speeds. And then I'm going to have either 3,000, or you move really fast at 500, or even faster at 800. And then the way I'm going to define when to choose what is I'm going to have a random selection. So in JavaScript, you have the math module, which is available by default. You just do math, and then random is the method I'm going to use. It's going to give me a random number from 0 to 1. Now, here I'm going to do the selection logic here. So current speed, I'm going to call the constant, and I'm going to pass it here, current speed. So you can see how declaring constants and variables is useful to make your code more readable. So here, current speed, what I'm going to do is I'm going to select the speed by using, you remember the brackets here, to select a specific index. And it's the way we're going to select the index that is going to be new concepts here. So if I'm going to use the math.random method, so it's coming from the math module, which is from JavaScript this time around. You have this access by default. There's nothing to import. It's going to give you a number between 0 and 1. And then you multiply this by using remember, multiplication is with a star symbol, by the length. Speeds.length. You remember, you could get the length of any array by using a dot length. The dot length. Now, this is not going to give you a whole number. That's why you need to use another math function called mathFloor. And you need to put in parentheses, because we're going to pass all of this as a param. And it's going to make sure that the number is round. So it's going to floor the number. So if it's 0.5, it's going to be 0. If it's 1.5, it's going to be 1, etc. It's going to floor it. That means we have a whole number here, which is going to act as the index. So now let's look at the result. Here we go. You see the speed varies. And then as soon as we go off screen, we're going to lose. So now it becomes the time before you lose. So here we can add different speeds. So what's nice about this piece of code is that it scales regardless of the length. So I can continue to add elements, and the code is still going to work this one. So that's something that you really want when writing code, is to have code that can be adapted, that adapts to the situation. When you are in situations when you're able to have code like that, this is really great. This is great code. So here I'm gonna, let's say 2000, let's say 4000. Let's see how easy or difficult the game becomes. Ooh, okay, it becomes too fast that it doesn't impact the gravity system, like the physics system struggles to handle. So let's add 1500. Here we go. All right, so we have a game. Now the last steps is to maybe add a timer and oops, add a timer, and yep. I'm wondering if it's too easy though. Here we go. Okay, so let's have a timer. So the way to display text is the same thing. You use game objects, and yep. So basically, we could use this. Have a counter outside. So const counter. Let's say 0, and that would be the score. And the longer you stay within the bounds, the higher the score. And every time this loop is going to run, we do counter plus plus, which is going to run, increase. And then here you could add at the top left corner. So what you can do is basically create a, actually you don't want to create a new game object. What you can do is you create a game object here, a const counter UI, and I'm going to use the add function. Here I'm going to use the text property, and because by default game objects are positioned to the top left corner, I don't really need to specify a position or anything. I can just add a text here 0. So the text component is from couplet text. So I'm just gonna put 0 here, and then what you can do is after incrementing, you can have counter.ui and then have access to the text property, and then you can modify the text with a new counter. Now remember, here it's a number, and usually you want to do like toString, using the toString method to be like really, how we say, to really be in the correct, do the correct way. However, in JavaScript, it works to just transform as a text, put as a text the number directly. Because remember, if you do the plus sign, it's going to concatenate it. So yeah, so just just put the counter here, and if I go here, assignment to a constant variable. Remember, we cannot. What do you mean constant variable? Okay, so this needs to be transformed into a variable, because we cannot increment it otherwise. And then that should work. So you see at the top left corner, you have 3, 4 as the loop starts. Whoops, and then I lost. So now what I'm going to do is I'm going to have the game over condition. So what happens is we need to, in the player logic, there's actually a component called the off-screen component. So if I go here at the end of the player definition, if I do off screen, by the way, use the line numbers to find yourself. There's this off screen component. That means if you, it's going to track when you're off screen. So now here, which is going to allow you to have access to a new method called is, or when the off screen is off screen. That's a boolean. That's not what I want. What's the function? Is off screen on destroy on exit screen. So this method is going to take in a function as its param, and it's going to run that function when the game object leaves the screen. So here, what you can do is display a message in much the same way using the text component. Working at big fonts like that is really not handy because it hides the actual code. So I hope in your editor you don't have those behaviors though. So here, game over. So at the top left corner, it's going to display game over. Now, if I let myself beaten, game over, you can see. Now you see the score continues though, which is kind of strange, but that's not what we want, but basically what I meant. So what happens is we can decide that we could define, so I don't want to complicate things. So what we could do is define a scene. So in Kplay, you have scenes. The way you can define them is just by calling the scene method, pass in a name you want to use for that scene, game over. And then the second param is going to be the logic that is going to run for that scene. And it's going to be an arrow function. Or here it's more handy to use an arrow function as always. So arrow functions are really useful in Kplay. Maybe I should have taught them at the beginning. Anyway, in a moment I'm going to teach you I'm going to point you toward a really great resource for JavaScript. So yeah, you're probably going to learn everything at once there. Anyway, so I named this scene game over. And what happens here, you can, instead of displaying the game over text here, you can display it here. Put a position, k.position component, call from within the center function method from Kplay, which is going to center the game object. And then here in on exit screen, I'm just going to do k.go, which is the method used to go to a specific scene. And I can go to the game over scene like that. So now if I go here and I let myself beaten, it's going to be game over. And then you need to refresh the page to play the game again. Now that's it. That's the game. And hope you learned a few things. And yep, it's pretty fun to play. It's a bit too easy though, so you can tweak the values. But at least you have your very first game. Now it's time to teach you how to export that game, how to publish it. So the way you're going to do that, the simplest way, put it on itch.io, which accepts web export or GameJolt, those websites. The way you're going to do that is you're going to first open up the terminal again. And then here, you can use this is the terminal window. You can use Control-C to cancel the server you started. Terminates the server. I think in macOS it's Command-C or Control-C as well. I don't remember well. It's been a while since I haven't used a Mac. So now here you're gonna run npm run build. Now if you run npm run build, it's going to transform this and build it for production, and it's going to create this dist folder. Now to check that it actually works, the output, you're going to do npm run preview, which is going to preview your build. It's going to create another local host. I'm going to copy the link though manually because I'm going to put it on my Edge browser. and it works, you see. Now, what you have to do is you simply open this in your file explorer, zip those into a folder, these three things, and then you can just drag and drop them in the itch.io thing. So itch.io have their own guide on how to publish the web. You just have the zip file, and then that contains the entry point, the index.html, the assets, and basically your output. You just put it there. You set it to web game, web export, and that's it. That's how you publish your game, how you get it ready for production. So now, what are the next steps? So you've learned quite a lot, and maybe too much, and it's time to relax, and also talk about the next steps. So here is my channel. So I make JavaScript and TypeScript game dev tutorials mostly, and you can see there's plenty of tutorials that are now accessible to you that you couldn't do before because you didn't know JavaScript at all. And so I recommend you can go here, but what I recommend more at first maybe is to actually no, you can watch my tutorials immediately after this one, but you can also check this interesting resource called the Modern JavaScript Tutorial, which contains everything about JavaScript. Classes, error handling, things that promises async await, something I did not cover at all in this project, this crash course, but is very present in my tutorials. I think I spent some time explaining it, but not all the time, not in every tutorial. So that's something I recommend you just look through, and I think it's going to really round up your knowledge. And what's really great about this resource, the javascript.info, is that you have a search bar, so you can search specific concepts. So if, for example, if I search promises, I'm gonna get specific, like the specific text that explains how it works. Now, yep, so this resource along with the MDN web docs, Mozilla. Yep. These are, I would say, the highest quality docs you can find regarding JavaScript. So thanks for watching, and I hope you're going to continue with your programming journey. If you have any questions, feel free to ask them in the comment section. And if you want to dive deep into making games, there is another crash course on the channel called Learn JavaScript Game Dev with Kaplay that you can watch.